Problem 6-122. Aniki has a sequence of numbers given by the formula t of n equals 4 times 5 to the power of n. What are the first three terms of Aniki's sequence? Well, that's pretty easy to start out with here. A little throwback problem. Let's go in here and let's say if t of n equals 4 times 5 to the power of n, we can say, all right, well, the first term obviously is going to be 1. So we're going to do 4 times 5 to the first power, which is going to give us 20. Second term, we're going to do t of 2 equals 4 times 5 squared. 5 squared is 25 times 4 is 100. And then let's do the third term. So t to the third is going to equal, t of 3 is going to equal 4 times 5 raised to the third power. Well, 5 to the third power is 125. 125 times 4 would be 500. And you'll see here, as we go up, we're just multiplying by 5 each time, which is our multiplier. So, Chalida thinks the number 312,500 is a term in Aniki's sequence. Is she correct? Justify your answer by either giving the term number or explaining why it is not in the sequence. So letter B. Well, we know that our output would have to be 312,500. So we're saying that's going to equal 4 times 5 to the nth power. Ooh, let's use some of our new methods for solving this. Let's first of all start out by dividing each side by 4. And let's see here, 312,500 divided by 4. Let's see what that's going to be. Let's just go ahead and do it on here. Trying to be efficient right now so I can go get ready for school. So divided by 4, we have 78,125. And that's going to equal 5 to the power of n. So now we could go ahead and do this using our power property of logs. We could say, all right, the log of 78,125 should equal the log of 5 to the power of n. And remember, we could take this here now, use that power property right here. Boom, n times log base 5, not log base 5, log base 10 of 5 equals our same log on this side, 78,125. Divide each side by our log of 5. So when we do that now, we're going to do log of 78,125 divided by the log of 5. We get 7. So that means that, yes, this is a term in the sequence. Good job, Chalida. Chalida is correct. It is the 7th term in the sequence. Smiley. All right. And remember, I guess we want to say explain the reason why, because our exponent ends up being a whole number value here, right? It's got to be a positive whole number in order for it to actually be in the sequence. If we would have gotten a decimal there, it would not have been. Last one. Elissa thinks the number 94,500 is a term in Aniki's sequence. Is she correct? Explain. Okay, so we could end up doing the same thing. We could say letter C, 94,500 equals 4 times 5 to the power of n. We go ahead and do the exact same thing we just did. Divide each side by 4. This is good practice. Do 94,500 divided by 4. We get 23,625. Is going to equal 5 to the power of n. Let's go ahead and use our power property of logs. So we're going to say the log of 23,625. In this case, I'm going to jump a step ahead here. Instead of showing this step and then rewriting this step, I'm going to go ahead and move my power out in front. I'm going to say n times the log of 5. Cut down on a whole step there, because I know what I'm doing. If you don't know what you're doing, go ahead and keep showing the other step there. That is completely acceptable. And let's check it here to see if this one works. Let's do the log of 23,625 divided by the log of 5. Oh, we're almost done. I can feel it. And we get 6.25 there. So if n is approximately 6.25 da 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 da. Okay, if that's what n is, then no, it is not in the sequence. Why? Well, because we got a decimal value here and we need only whole number values in our for our exponential values there. So our term numbers can only be whole numbers. If you want to write that in, that'd be a great answer. So term numbers may only be whole numbers. It's actually more natural numbers, but we'll get into that another day. All right, so this is problem 6-122. Hopefully this helped you out with that one. If you have questions, make sure you ask your teacher. There's only one more problem in the homework. Thanks for watching.